Simple English. No confusion.
Welcome to the channel, friends. Today we are going to discuss about micro-partitioning and clustering in Snowflake. So coming to the partitioning, in traditional data warehouses, we used to create static partitioning on large tables to achieve acceptable performance and enable better scaling. However, static partitioning has a number of well-known limitations such as maintenance overhead and data skew. In contrast to the traditional data warehouses, Snowflake Data Platform implements a powerful and unique form of partitioning called micro-partitioning. The micro-partitioning delivers all the advantages of static partitioning without the known limitations. Group of rows in a table are mapped into individual micro-partitions organized in the columnar fashion. Each micro-partition contains between 50 MB and 500 MB of uncompressed data. And we need to note that actual size in the Snowflake is smaller than this 50 MB because the data is always stored in compressed format. Micro-partitioning is automatically performed on all Snowflake tables, and the tables are transparently partitioned using the ordering way of the data as it is inserted or loaded. So because of this micro-partitioning, the overall performance of Snowflake has been drastically improved because we are going to partition each table into very small set of data. So now look at clustering. So clustering refers to grouping together of objects with similar characteristics. The purpose of clustering is to increase the scan efficiency and the overall performance of the querying. So now let us see the above example. So I am performing a clustering on the above data based on the date column. So now all the data which is representing 1st January is in one partition, the data for the 2nd January is in second partition, and the data in the 3rd January is in the third partition. So making my life easier to scan the objects. If I want to perform a query based on the date condition, so now my metadata knows where it need to go, in which partition it need to go, and then scan that partition and exclude the remaining partitions. So which makes the overall querying very fast for Snowflake, and also this overall scanning also gets reduced because the data knows in which partition it needs to look into. So now coming to the clustering by the cluster ID. So here I am clustering the data based on the cluster ID, and each micro partition is having its own range. Snowflake metadata stores the range of the clustering ID on which is available in that partition. It stores the minimum cluster ID and also the distinct number of rows that are present in that particular micro partition. So, and when I do a query on the customer ID or cust ID, I will be directed to the partition which has that cust ID, and the overall scanning process will get minimized. So, which will automatically improve my querying performance. In Snowflake, the clustering happens automatically and we don't need to do any manual clustering. Also, there is an option to recluster the data for the table that we have created, and that reclustering will cause to consume some of the Snowflake credits. Now, let us look at the key points to note for micro-partitioning. So, the micro-partition is automatically performed on Snowflake tables, and the micro-partition don't need to be explicitly defined upfront or maintained by the users. As discussed, each micro-partition contains between 50 MB and 500 MB of uncompressed data. Snowflake stores metadata about all the rows that are stored in micropartition, the range of the values of each of the column in the micropartition, and also the number of distinct values. The columns are also compressed individually within micropartitions. These are some of the key points that we need to note for the micropartitions, which can be asked in any one of the interviews and also in the Snowflake certifications. Now let us check the key points that we need to note for clustering. Once clustering key has been defined on the table, no additional administration is required. All the administration activities will be taken care by Snowflake. Snowflake recommends a maximum of 3 columns per key for multi-terabyte tables. So this is for optimizing the overall performance, and if you are increasing the cluster keys also might cause to degrade your overall performance in a multi-terabyte table. Clustering improves scan efficiency in queries by skipping the data that does not match filtering predicates. This we have already seen in the last example. Reclustering in Snowflake is automatic. No maintenance is needed. So reclustering is also done automatically and no maintenance is needed for reclustering the tables. The reclustering also results in storage costs consume credits. So this is also one thing that we need to note, that the reclustering will also results in the storage cost and also it will consume credits as you are reclustering your entire table. So reclustering can be done manually also and automatically also. Some when your data is increasing day by day, there is a chance to recluster your data, and if you are not changing your cluster keys, Snowflake will automatically recluster your data. Are some of the main points that we need to note for micro partitioning and clustering, and these two are one of the major features that we need to know in Snowflake. Thank you. Hope you like my video. Please share and subscribe.